Ladies and gentlemen, I am hoping this fourth video is going to complete our chapter 10. As you can see, I've stocked up on caffeine and gross, cheap sugars and artificial nastiness. Anyways, remember, you have my phone number, so you can call me or text me if you have any questions with this stuff. So let's get back to business. Number 19. Salaries from 42 randomly selected Maryland teachers and 38 randomly selected California teachers are shown in the table below. Use alpha 0.05 to test a claim that the Maryland teachers make 10 grand more than the California teachers. Assume all conditions are met. All right, the ho and the ha. Let's let Maryland be 1, Cali be 2. What am I going to put here? Anybody? Sarah? Right, greater than 10,000. It's not 0 anymore. It's 10,000. Therefore, this would be less than or equal to 10,000. Or I guess you could put equal to, but that's fine. Test stat. X bar 1, X bar 2 minus mu1, mu2, S1 squared N1, S2 squared N2. X bar 1, 4. Yeah, that is not a good salary. $49.80 a year? That's terrible. 4980 divided by 52 weeks, divided by 40 hours. They're looking at $2.40 an hour. Not good. I think that's supposed to be a 9. That would be a lot better. 94980 minus 8830 minus 10,000. 0 doesn't go there, 10,000 does. Divided by this. Square root, and we're going to have to do this by hand, so we get 2.05. I can't do this in the calculator because when you do that in the calculator is doing this to be 0, not 10,000. So the calculator doesn't know to do that. So the p-value, t is greater than 2.05, t CDF, 2.05, 99, 37. Got to take the minimum because you don't have the calculator to find you the calculator degree of freedom. You could use that insane formula I showed you maybe on the last lesson, but no, nobody would ever do that. This is good enough. This would get you full credit on the AP also. As long as you tell the AP what degree of freedom you're using and it's consistent with the p-value that you found, you're good to go. So since p is less than alpha, reject HO. So we have convincing statistical evidence to say Maryland teachers make 10K more than the Cali teachers. Ta-da. All right, nice. All right, I'm skipping 20. Inference for experiments. Permutation test, randomized distribution, that. Okay, sampling. Distribution. At least in this chapter, we did the sampling distribution for this, and then we also did it for proportions. I'm just going to talk about that for a second. So we have a population. We have another population. We take a sample from this population, calculate some proportion, take another sample from this population, calculate some proportion, subtract that proportion, and then plot it. So then we get that. So we do it again. Take a sample, find the proportion, take another sample, find the proportion, subtract it, plot it. Now they don't have to be the same size, but then we get some value. We find billions of these, and it makes a sampling distribution for p hat 1 minus p hat 2. Sampling distribution. A randomized distribution involves experiments. Thus the word randomized. So if you go back to number 10, let me go back to number 10, find it somewhere. The one with the drugs, gemfibrozole, the one I can't pronounce, and the control group. So we tested the claim to see if these drugs are, what were we looking for? Lowering the risk of heart attacks. So when we do a hypothesis test, we were assuming that they were the same proportion of heart attacks. So if these drugs actually were the same, I should expect 0 to be in the middle. So what the randomization test does, it says, all right, we have a population of 2051 and another population of 2030. And we're going to take samples, size 56, and size 84, and then we're going to kind of do the same thing. So let me, actually here. So a permutation test is when you redo an experiment as many times as possible to create a randomized distribution. Sampling distribution is used for random sampling. Randomized distribution is used for experiments. So for that heart attack experiment, basically to create a randomized distribution, you had 4,081 total people. And we put some in that group and then some in the placebo group. Now you don't need to really look at the math on this one of how many possible combinations there are, but if they were truly equal, we would have a mean of 0. All right, we're going to end up getting this as the standard deviation, and then we say, oh, well, my results fell here, assuming that they were equal, and the computer kind of did a randomization of it. So it's almost like a sampling distribution, but it's for an experiment, but you don't really need to know anything more than how to do a p-value if you see it. Okay, so we are pretty much done with chapter 10. Make sure you're reading the book, but for proportions, P1 minus P2, the confidence interval, P hat 1, Q hat 1, organize these formulas, P hat 2, Q hat 2, N2, 2 prop, Z int, all right, no pool. If we're doing a hypothesis test, see, this is a CI. If we're doing a hypothesis test, P at 1 minus P at 2 minus P1 minus P2. P pool, Q pool, N1 plus P pool, Q pool, N2, and U pool. And the pool is this. And that's 2 prop Z test. So that's the only one that you pool with, is with a hypothesis test. And then remember, when we're dealing with means, so these need to be organized in your mind. When we're dealing with means, I guess it's on this sheet, but know what they are. Confidence interval, degree of freedom, never pool with the means. Number 13, number 14, go through it.